Hello guys, my name is Zhao Yu.
My name is Jaewon Jo.
And today we want to talk about our final project, LED Bully Pool. First, I want to talk about our inspiration for this project. So, when we were doing online search for our final project, we found a snake robot, and we see that lots of scientists are inspired by nature. So we want to do a bull robot for our final project, and this bull robot can be activated and chase and search for red light, and most importantly, it can be deactivated and become calm by green light. And when it is calm, it does nothing but stand still. And here's our part list. So the core of our bull robot is the Arduino board 10Z. It can compile our code and control the behavior of our bull robot. And we have the photoresistor and color filter to do the color detection. And we have the mobile robot, so this machine can move just like the bull. And we have LED, NMOS, and diode. These parts can allow us to do the state indication, and it can do the motor control. And most importantly, we have breadboard and 9 volts battery, so it can move in any place, not just in the lab.
Here's the schematic of our circuit. There are 4 different parts to our circuit. First, we have our motor control. As you can see, the 2 motors on the mobile robot, left and right side of the robot, are controlled by this motor control circuit. And next, we have our power supply. The 9 volt battery provides power to the motor, as well as the 5 volt voltage regulator, which provides power to the 10Z here. And next, we have the state indication. The 2 LEDs, red and green LEDs, they indicate the state of our bull, calm or mad. And next, we have our color detection circuit. Here we have our photoresistors in series. So the photoresistors will change their resistances based on how much of the colored light is shining on them. And all the parts of the schematic circuit, they're connected to common ground. We have our pseudocode here. During the setup phase, the bull starts off mad, and then it reads the baseline values for the light condition. And during the loop, while the bull is calm, it first checks if the bull is calm, and if red light is detected, the bull is activated and is set to mad. And while the bull is mad, it will chase and turn towards the red light. And if the green light is detected, the bull will be set to calm. Otherwise, the bull will just charge forward. In our testing process, we did a step-by-step testing process. First, we did a component level testing by using a power supply and DMM to build like a simple circuit and make sure each component worked properly, such as the motor or the NMOS or diodes. And next, we did a circuit level testing by making the individual parts of the circuit, such as the motor control circuit or the light detection circuit, and make sure they all work properly before integrating them all together to make the full circuit. And next, we did a software testing by going on the Arduino and then opening up serial monitor and making sure we were reading the proper light readings and running each test, and then make sure the bull runs properly and fixing if there's any bugs or stuff. Yeah.
And I want to talk about our challenge and solution. So one of the major problems we face in this project is the inaccurate light detection. We have this problem because we have 3 photoresistors in series. So when we shed light on one of the resistors, it also affects the value of the other photoresistors. Therefore, we adjust the boundary for light detection. This can allow us to have the bull to conduct the correct behavior when detecting red light or green light. And also, we adjust the angle of photoresistor so it can capture the light without influencing our other photoresistors.
Second problem we had was making sure we had effective motor control, because the motor by itself will just run at full speed when it's connected to the power supply. So we achieved that by controlling an MOSFET with the PWM signal to achieve low side switching of the motor.
And here's our results. We successfully built a basic blue-light robot that can chase in turn for red light, as you can see in the video. And also it can also be activated and deactivated by red light and green light. And we have the bold exterior design. So we have the horn, we have the tail, we have the legs. And the last one, we have learned lots of basic circuits and components in this class. In this project, we have successfully integrated those basic components and circuit into one application, into this bull robots. And the future works. If we have more time, I want to adjust the speed based on the distance of the red light, because we don't want it to simply just chase red lights. We want it to conduct different behavior based on the distance of the red light.
Also, we can definitely improve on the color detection of the bull and as well as the accuracy, because sometimes the bull just sways left to right depending on the lighting condition of the room. So we can definitely improve on that to be more accurate and precise.
And the third one, we want to make the bulls make bull-like sounds, because as we said, we are inspired by nature, and we want this robot to be just like a real bull. And the last one, we want to have different functions when detecting other colors. There can be a wide variety of functions, but one of them I have in mind is to when it detects blue light, it will be afraid and draw backward and like reverse. Yeah, and that's it for our project. Thank you.
Thank you.